Hi, welcome to Flutter at Scale, the talk about how we built a large mobile banking app with over 25 Flutter developers and over 200 people involved in the project using Flutter. I'm Mateusz. I'm head of mobile at Linkcode, using Flutter since early beta in a Credit Agricole project, because that's the project that we'll be talking about today. I was the leader of the technical squad, which I will be talking about later. And you can find me at this Twitter handle.
And hello everyone, I'm Albert. I'm a Flutter developer since its very first public release. In the Credit Agricole project, I worked for almost 2 years as a developer leader for the overall design squad. And yeah, you can also find me on Twitter.
Okay, so first let's set some terms, just to be clear. So what it means for a project to be small. For us, let's say approximately, a small project is, for example, a project that you can do for 2 months with 2 developers. And what's special about this class of projects is that you know almost every piece of code in there, in the code base, and you got similar business knowledge to your colleagues. And probably there's a big chance that a backend developer also sits by your side and you can communicate with them in the real world. Yes, so what it means for us, for project to be large, there's code that you have never seen. This is one of, I think, the most special things about large projects, that there's a code that you have never seen and probably you will never see. Because, for example, you work on loans, but you don't know anything about loyalty club or transfers, because there are 2 different business domains. You are in 2 different teams than your colleague, and you just never, you have never seen this code. So there's hundreds of people involved, and each of them works in a whole different way. So let's tame it. But what was our project? Our project was over 200 people involved, not only from IT, I mean like the whole project, business people, external people, IT people, and so on. So about development, it was over 25 Flutter developers in more than 10 squads, because we called them squads, the teams, the agile teams. So as you can see, we listed the squads in here, and we emphasized 2 of them. The first one, overall design squad, which Albert was the leader of, and it was all about the design and design system. And squad number 13, platform framework, which is also called technical squad, which I am a leader of, which is all about things that no one wants to do, and we'll be also talking about that later. Yeah, so when we thought about how can we deliver a large project, we split it into 10 key concepts that helped us deliver. But since we got 40 minutes, we'll be only covering half of them. And if you want to get more knowledge and the rest of the concepts, you can download a free guide on building mobile banking app. And the QR code for that will be available at the end of the talk. And also on our Linkcode stand, booth number 7, you can also get the ebook. Okay, so let's start with the first concept, which is code ownership. So it's a seemingly simple thing, because in small projects it's pretty simple. It's implicit. There's a single team that contributes to a single code base. They create it, they own it, they maintain it, they develop new features, fix bugs. Everyone knows everything, and we just don't have to think about it. So if your project has, for example, more than 25 Flutter developers that work on a single app, in a single code base, single monorepo, is everyone responsible for everything? Everything as in nothing? Because yeah, the answer is no, because there's always an excuse. You probably have seen that in your life as a developer. There's always an excuse, and you can say, someone else is responsible for this piece of code. I've never seen it. I won't maintain it. I don't care about it. Or someone will, change jobs and stuff like that. So yeah, there's need for the boundaries. because otherwise, when we go with this code and we develop it another year, there would be no one responsible for some pieces of code, and we need to put up some boundaries and impose some rules. So let's introduce explicit code ownership to disallow no man's land, and let's set some rules. So what are the rules? Every piece of code is owned by a team. A team and not a person, because person can change teams, can change jobs, can go on some long vacation and stuff like that. Thus, it will be unmaintained. So we have to have it owned by a team. So the second one is that the team takes full responsibility of the code. And what it means is that they will maintain it, they will develop new features in there, they will fix bugs there, but the most important thing is that they will decide if they allow or disallow any new code from outside. Because we still want to be as agile as possible and quick and smart in our job. And if, for example, you have a dependency on some other team and you know that it's blocking you and you know that it's just a change of one line of code and you want to do it yourself, because why not? We still want to be able to do that and allow it, right? Because why asking someone to do this change and tell them what line of code and how they should change it? The issue is that just when you create this pull request or merge request, the squad that owns this piece of code, they just have to allow or disallow it, right? You need their approval. This is the most important part, because they are responsible for this piece of code. And the third rule is that there are no exceptions to those rules, because still, otherwise, it won't work. Okay, so we have rules, but how to define the boundaries? So let's get back to the where to put up the boundaries so that this is this piece of code for this team. So for us, local packages was enough. So just each Dart package has exactly one explicit code owner that we have in our docs. But you could say there's always something in common, like formatters, utility packages, stuff like that. And it's true, but they still need to be owned by a team because we got no exceptions, right? So here comes the technical squad, which I'm a part of. And this is the team that does and maintains things that no one other wants to. And this is really convenient to have one squad like that in your large project. So a summary of that part is that someone has to be responsible for every piece of code. Okay, so let's go to the second concept, which is about project structure. So we can look at project structure in a lot of very different ways. You could probably have seen in your life a lot of diagrams like this. So we have 9 classes from 3 different domains: transfers, loans, and benefits. And we have some pages with UI, qubits with application logic, and repository with some data access layer. So you probably heard of layers and stuff like this. So we can have a UI layer, application logic layer, and data access layer, and stuff like that. But the main question that raises from that is who owns the package, right? Because who owns repository package, who owns application logic package? And to answer that, we can refer to Conway's law, which is a very popular aphorism in computer science, and it's very helpful. So it states that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. So basically, it means that how we communicate in our project will reflect onto our code. So how do we communicate? On a daily basis. And daily is actually a keyword in here because, there are daily meetings. So is there a repository squad daily? Probably not. But there's a payment squad daily. There's loan squad daily, account squad daily, because there are payments business experts, people from other side of company that we depend on, often people from other companies that depend on us, and so on and so on. But the one and only thing that connects us all is that we all work on one specific business domain, business feature, for example, transfers or loans. So let's try to project our communication model onto our code. So we can have the same 9 classes like you can see, but just we can group them in an orthogonal way. So we have benefits package, loans package, transfers package. So everything related to transfers is in one package. So now I know who I should ask about this code, especially if we have new developers. But what about the package structure itself inside? So we can actually go recursively with this idea, and we can just go with feature-oriented structure so that any code that's related to some feature sits in one directory. So for example, we have some lending package that's about loans, and we have some agreement for the loan. We have some documents and signing the documents. So as you can see, all of stuff related to agreement documents, blocks, docs, pages, widgets, and so on, it just sits in one directory. This is especially helpful if you have to onboard new developers or they switch teams, because they can see like all the code is in there. And for example, if we had 200 repositories in one directory, which are from any piece of business domain in the app, it would be a hassle to search through that. But how to do the wiring between all of those, because we have a lot of packages and a lot of features. And I got this question, I added this slide because I got this question before when we made this talk. So how to do the wiring between all of those? So remember that your app package, your entry point to the whole app, this is the place where when you can do this all this stuff about wiring, because your entry point, your app package still depends on everything that your app is, and other packages depend on. So you have access to everything in there, and you don't have to break any rules or stuff like that. So we, for example, use providers for some dependency injection, and we can just expose them publicly from those packages and wire them up in our routes widget or stuff like that. And if we used any other dependency injection, it would be the same. It's not related to that. It's just that your app package connects everything. So the summary of this part is take a domain-oriented look when you structurize your project, because it's always helpful. Okay, so let's actually start working on the code, because we have those diagrams and stuff, but we want to write our first line of code. So we have those packages, and we can see this, and we can, think, okay, what if I, for example, want to run tests where applicable, or generate code in packages that have build runner inside? It might be a hassle to do it by hand if you have like 60 packages or so. So what we actually want to do, we want to run things in a multi-package environment, right? So yeah, there are tools for that. And there is one tool for Dart especially. It's called Melos from Invertase. Probably you already know it. It's a tool for managing Dart projects with multiple packages, exactly what we need. So it's basically a task runner for us, and we used it for a couple of tasks. For example, reconciliation of package versions, so that we have the same package versions across all 60 packages, running tests where applicable, generating some code, and so on. So this is pretty simple. In large project, you just need a task runner, period. And one more thing about this kind of stuff. Use one linter package in your project. You'll thank us later. Because if you use one lint package and you just include the rules from that lint package everywhere, it's much easier to refactor that later, because lints are something that change over time and constantly change over time, and it's normal because new Flutter versions come out and Dart versions come out. Some lints got deprecated, some new come up. So we have those weekly meetings with all Flutter developers when we can discuss about what lints we want to enable, disable. So it's much easier to do that in one file. Okay, so let's go to another topic that's very needed in enterprise. And if you worked with enterprise clients, you probably know that they will ask about, what about end-to-end integration testing? It's a requirement for us. Yes, so we tried to use Appium Flutter driver, because in case of our client, there was already knowledge about Appium stack in the bank. So we tried to integrate with the Flutter app, because normally Appium drivers are for native apps. And to be honest, it was pretty unstable for us. We had a lot of issues where we had to fork some Flutter test, Appium Flutter driver. We forked that also. And we had a lot of issues because it didn't work like it works with Flutter test behavior. Like normally in your widget test, you would expect another behavior. Or for example, it's a black box solution, so we had to type weakly typed strings anywhere. So it's easy to make mistakes. And also we couldn't, for example, find first widget or stuff like that. So QA engineers were telling us that there are a lot of things that they can't do. We had to fork the Appium Flutter driver to augment those methods for them. Then we had to fork a Flutter test to change some behaviors because they said that it should be some other behavior because they are used to it from other framework and so on and so on. And after those experiences, we decided to create our own end-to-end UI integration testing framework for Flutter, which is called Patrol. Maybe you know of it because we had a talk about it yesterday. So if you want to know more about Patrol and why it's an enterprise-ready solution, you can check out a link code stand, booth number 7, for more information. Also, we got a contest, the puzzle to solve, and if you solve a puzzle using Patrol, you will get a reward.
Yeah, the project of this scale, having a design system is really a must because you need consistency throughout all of your different screens, throughout all of your different components, and the reusability between them. So just to remind you, we've been working with over 10 squads, with over 10 teams that were writing Flutter, and except for those two, for the overall design and the platform framework one, all of those developers were creating some business values. They were creating screens, pages in Flutter that were utilizing all those components, and there were a really big amount of them because we had more than 350 components created for our design system, both from the really small ones that were used in only some places to very complex ones like scaffold alternatives and stuff like this. And each of them had their own dedicated story in the storybook. So a question may arise: what do we actually need? What do we actually need to do to have a good design system that provides value to all of those squads, that is convenient for all the developers in your project to use? So let's start with the basic concept that you need to establish at first, and this is tokens. And let's talk about a design side of work for a moment. So what are tokens? Tokens are basically something like variables in our code, or maybe even constants. This is basically something defined, something like a typography. So your font size, font style, all of this stuff that's used throughout all of the different places in your application, in your project, in your mockups, in Figma or in whatever tool you use. So once you have all of those tokens, you use only those tokens in those designs. So this button uses this headline 5 in this example, and not some hard-coded values that define all the font features. And it's similar to in the case of a color. We also have all the color tokens defined, and those color tokens are used in our components. And there's actually a plenty of other things that we can tokenize, that we can make a variable of, stuff like box shadows or elevations, spacings, or maybe even other stuff. Figma recently had a massive update, and they allowed us to tokenize much more things like those spacings, but also your designers could even use the Token Studio, which is a really massive plugin that introduces a vast amount of options to tokenize stuff. So we have those tokens in our design, so that designers shouldn't create anything illegal, let's say, using some stuff that they weren't supposed to do. We also need to express those tokens in the code to prevent using the same illegal stuff, hard-coded values throughout our code. And let's start with the typography, which is basic, the easiest example. How we actually approach the problem is we simply extended the base Flutter class, the text style, and created our own. The CA is a prefix for pretty agricole. It's just to differentiate visually all of the different classes that are ours from the Flutter ones. And the One very important thing that you can see in this code snippet is the private constructor. It could be private, it could be annotation, internal, whatever you like more. And because of this private constructor, only your package, or rather your library, is allowed to create instances of such CA text styles. So you could create somewhere next to it a container for all of the tokens, for all of the typography that the designers created, and that is should be used by the developers and not just some hard-coded values that a developer thought would be the best because of reasons. And thanks to this, all of our components can utilize this type. So we don't accept just a regular text style anywhere that the developers can pass whatever value they like, but the CA text style, which they can only use using the CA text styles headline 5 for this button, for example. Yeah, and it would be very similar in other cases, like the spacings, box shadows, maybe some other types, because it doesn't really depend on any other thing. But there's also the case of colors. And colors, usually our applications have a few themes, a few color schemes, a few color palettes. We can have a light and dark color palette, maybe a high contrast one if we are creating an application for government or someone that has the accessibility requirements much higher than usually, or maybe you are personalizing the experience for a user where certain types of accounts maybe have slightly different color palette. And the story here starts similar. We also have custom class for this, like for the CA text style with the private or internal constructor. We define the holder containers for all of those tokens, for all of those values. So we have the color scheme data, similar to what we have in Flutter, and the color schemes themselves, light one, dark one, probably other ones. In the Cruddy Agricole, we actually also had the light and dark, and also a company light and company dark, which were for the not individual but company users. So they would see that the application is in the business context. Yeah, so we have all of those color tokens, and we need to somehow pass them to widgets. And we, of course, use the inherited widget, like one of the most basic things in the Flutter world. We simply pass this color scheme, this light or dark color scheme. This inherited widget is above the whole application, above the material app or widgets app, so that all of the widgets can simply go get this value from the inherited widget, which is actually provided in some wrapping widget that we this is the place where we decide what kind of scheme we actually want to display. And because it's above the material app, we don't have access to the theme of context, brightness, or anything like that. So we need to rely on something a little bit more low level, like the platform dispatcher brightness from the widget binding. And using this, we simply decide whether we want a light or dark theme. Yeah, so in our widgets, in our components, in the design system, in our common UI library, we can just use the context.colors, for example. That's an extension method, or rather extension getter, that returns us this color scheme. So it's very easy and very convenient for the developers to use. And I can already give you some tips regarding this stuff. So the first one is, if you have some text widget, some custom text widget, because of some reasons, because, for example, you want to only accept the CA text style, your custom text styles or colors, it's very convenient to have the text style separate from the color. So developers don't need to deal with the copy width, and you don't need to override it. And it's simply much easier because the style and color, at least in all of our experiences, weren't really that much connected. And also there's a second tip, which, I put 2 exclamation mark emojis because it's really important, is to not use to think well about creating those design tokens, how they should look, how they should be named, how they should be utilized. You don't want to start your project with some light theme, or maybe your designers don't want to start a project with a light theme and naming all of your color tokens after the value of this token. You don't want to have a primary and white and black color tokens. because you may stumble upon a problem when you want to create a new color theme, like in this example. So this is a very simple application. It uses a color scheme that only has 3 colors, the primary, white, and dark. And well, everything looks good. But now we want to add a dark color theme to our application. So because our application is big, we have plenty of screens, we just change the color scheme values so that it's provided with this inherited widget to all of those components. And we probably assign the new values like this. So the primary color is a little bit more dark, the white and black is reversed. And this results in something like this, which is of course problematic. The black and white still are contrasting with each other, but the color of the text in the up bar is not, because the primary and white color, they weren't meant to contrast with each other. They weren't related to each other as a design token, as a color token. Those were just some color values. So if we would follow the example of the color scheme in Flutter/material, and you would use color tokens that express this relation. So we have a primary color and on primary that always contrasts with the primary, and similar with other ones like the surface and on surface. Then when we create a dark color theme, we can also take care of this contrast, and our application looks well, readable, and it looks exactly as it should. And yeah, this enabled us to create such experience for our users in our application, to introduce such dark theme. Other thing that we also, I think, want to have when we have so many different components, so many different widgets, is golden test. And just to remind you, or maybe tell you if some of you don't know, golden tests are very similar to widget tests when it comes to writing them. You actually write test widgets. You pump some widget that you want to test, like the CA badge with some hello world text. But instead of making expectations on if this widget has some other widget, if it has some text, if some icon is visible, you do the matches golden file. So it basically prints this widget inside the PNG file and checks whether it's the same as it was in the repository before you run your test. So it basically creates a PNG file that's, well, this is the CA badge with the hello world text. And this is a great tool for spotting and preventing various regressions, various visual regressions, because when you make a change somewhere in your application, in some small place, or maybe some global change in all of your components, you have this difference in the goldens in those images, so you can manually look at them and spot whether this is an intended change or whether something looks completely off, and you know there's some regression that you need to take care of. So it also boosts your confidence with some more low-level changes when you are adjusting the colors because you want to support the WCAG new version guidelines, and there you need to have a different color contrast between all the colors, or maybe the branding changed, you know, stuff like this. But unfortunately, golden tests come also with some problems related to generating them on various architectures and on various platforms like macOS, or between Windows, the goldens can differ a little bit, which will make your golden test fail, which is a bummer, but there are solutions available if you just Google it. Yeah, so when we check out our goldens inside the repository, we can also have such beautiful slices previews in our GitHub, or whatever we use, so that all of our code reviewers can see what actually changed, or maybe what did we create and will approve based on that, and not only on the raw code. There are a few packages that may be helpful in writing golden tests. The golden toolkit, which helps you create different matrices of devices that maybe you want to have a golden for light theme, dark theme, for different text scales, for maybe for the accessibility feature when you have a bold text everywhere, and Alchemist, which helps you a little bit with this differences in platforms back. So using this golden toolkit, I created a matrix of 2 devices, so to say, the light theme and dark theme, and now all of my Golands are produced twice in those two themes. And also Golan Toolkit helps you spot the visual difference in case of a failure. So you can see what pixels did actually change in our Golan test when there was a failure. Other thing that we also utilize in our common UI, in our overall design squad, was Storybook. And Storybook for us developers, was a place for the developers to create those widgets in isolation. So it's not inside the application. We don't need to click through various screens or to sign in, whatever. There are no surroundings that may distract us or may impose some constraints. So that we focus only on this particular component that we have in Figma, also in isolation. It's also a place for other developers, because if those people from other squads want to create a screen, maybe they want to first look what widgets it's using and play with it in the storybook to see how it looks, how it behaves, whether it's really what they need to use. This is also a convenient place for showing the increments on sprint reviews. Our storybook was in Flutter, so we could simply do Flutter build web and host it somewhere, and then open the different widgets in different cards in Chrome, whatever. And it's also a place for designers or really any stakeholder that is interested in how the component looks, behaves, whether it's correct, whether it's as it's supposed to be. And this is how our storybook looked like. This is a storybook_Flutter package that was a long time ago, like 2 years ago, that when it was created, it was heavily modified to accommodate all of our needs. On the left side, we have a catalog of all of the widgets in some tree hierarchy with a search. On the right, we have the knobs with all of the with all possible properties for the component, all of the different values. We can also switch the and this is in this example, you see some button, a very simple, you could say, widget, but it is also very helpful to much more complex widgets, components. So what you see right now, this CA scaffold panel over, very fancy name, is probably the most complex widget inside the whole project. And widget book, or rather storybook, was a great place to test whether all the scrolling behaviors, all the showing and hiding the different parts was working correctly. And if I were to you maybe even met widget book guys here at the conference. Their open source solution has all the features that we needed to create customly out of the box, which is really nice. And if your team also needs some additional collaboration features or some Figma integration, they also have a cloud solution. Yeah, and this was all regarding our presentation, but it was certainly not everything when it comes to the broad topic of having a Flutter at scale. So if you have any questions, if you want to learn more, be sure to read our ebook on the topic. We're also available at our stand, at our booth at Linkcode at number 07. And yeah, this is the place for your questions now. Please make sure to go to the microphone to ask them. That's it.